So we generally don't introduce guests, but I am going to orient. I know we always forget because we just start chatting.
Yeah, that's
but
all right.
I am going to orient us because you might have read Hamish, and the thread was, in telling Brad Terpstra from Halter, head of network, what it is that we might talk about today. Because I find the ag tech thing interesting. The product is fascinating, but I am really curious. To rewind maybe backwards from Halter, how you ended up in New Zealand, can I take a leap and assume it was through the America's Cup?
What does it mean to have a human in the loop?
Human in the loop.
Human in the loop.
What in the world is a human in the loop?
Being a human in the loop.
AI in the loop. Humans in charge.
Welcome to Human in the Loop. Can I take a leap and assume it was through the America's Cup?
You can, and that would be correct. Yeah.
So tell us about the decision to stay here in New Zealand, coming off working on America's Cup boats.
Yeah. So, the America's Cup had ended. Obviously, things didn't go as well as we would have liked. And typically with the Cup campaigns, there's a delay kind of in between one ending and the next one starting while they rewrite the rules and kind of figure out a whole lot of admin. So you kind of enter this like downtime period. Most people take 1 to several months leave because 1, nothing's really happening, and 2, you've been working flat out for 6, 12, 18 months, kind of depending on what role you sit in. We were kind of hanging around in Auckland. We didn't have a need to go back to the US immediately. Since the Cup was in limbo, the team actually left all of their stuff here. And so my wife and I talked about it, and we were like, well, we don't have to leave straight away. So I said to the team, hey, I can kind of keep working on some projects in the background, watch over the stuff in Auckland, because everyone was pretty much heading back, and like kind of keep the lights on, so to speak, and just kind of hang out in New Zealand until we figure out what's happening. And so that's when I got contacted by Halter, and they were like, oh, we have this role that is what you did in the America's Cup, basically, and would you be interested? So I went and interviewed, and quite honestly, I went into the interview like not expecting to take the job, but as you said, the tech was interesting, and the people seemed quite interesting, so I was just kind of keen to like learn more. So chatted to them, was really like really fell in love with kind of the leadership team and the people there, and the product was quite interesting. And I said to him, hey, like I'm going to do the America's Cup thing again. Like, I really appreciate the offer, but don't have any interest. But like, I do have a bit of a flexible working schedule and can do a bit of part-time while you like find the right person. Then, roll the clock forward 9 months, and then I was the right person. And so then started full-time with them, and then that obviously kept us here in New Zealand. So my wife's a veterinarian who works at Animal Referral Center, and she really likes the office there, and we really like New Zealand and the people, beautiful country. So yeah, and so here we are, 5 years on now, I guess. And really loving it. We bought a house in Grafton about 1.5 years ago. And
congratulations.
Yeah, thank you.
So you said you were kind of tapped by Halter for doing the same thing as you did on the boats. What is the same thing?
Yeah, fair question. And I mean, in fairness, the job there were some similarities, but it looked a lot different. So for the America's Cup, I was running, all the IT. So that was all the way from the computers that sat in the boats and operated the boats through to provisioning people's laptops, our high performance compute cluster, running all of our design simulation software. Kind of primary responsibility, especially on race day, was the network that the boat, all the chase boats and the like racing boat talked on. So we had 3 primary chase boats that had engineers and support crew and everything on it that would chase the yacht around whenever it left and went sailing. So that was one of the primary responsibilities, that all the telemetry and video data shipped off based on that. So was really important. Things are happening like very fast at 50 knots or, roughly like 45 miles an hour. And
2 units, I have no
Oh yeah,
experience
sorry.
with.
And then I remember that we're not dealing in freedom units here. So
sorry, you're not American. They're talking knots. Oh, you're not a boatie.
95 kph.
Yeah, yep, cool.
80 kph, somewhere in that.
Somewhere in there.
Yeah, somewhere in there. So
Roughly double.
like roughly what a car is doing on the motorway.
Okay. Motorway speed.
Yeah, motorway speed. And so the engineers are watching the data live as it's coming off the boat, and when things are happening, like there's a lot of you're very much on the design edge of what we know is possible. And so the loads and things that are happening, you have a bunch of limits and alarms, but you never really know. And so it's really important that a lot of people are keeping an eye on that stuff as it's happening in real time, so that if something doesn't look right, you can kind of shut it all down. Because a catastrophic failure, to stop and take a look at something, you lose maybe 30 minutes. But a catastrophic failure, the mast falls over, or something like the foil breaks, something like catastrophic, and you lose weeks. And the adage with the cup is that you can buy everything but time. And so you're always kind of optimizing for how do we do it quicker? How do we save time? How do we shave 30 minutes off rolling the boat out every morning? How do we shave 30 minutes off our checks? How do we shave 10 here, 15 there? Because that's all, especially compounded over the amount of sailing days you put in, like that comes back in days, and it just speeds up the feedback loop. And there's lots of positive benefits, which is true in any business environment. The cup's not unique in that. I think it's just the date is so finite. It's like, this is the day that you have to be ready to race on. Like, the calendar does not move. That gets announced 3 to 4 years before you even start thinking about building a boat. And that's the day. And you got to be on the race course on the day, ready to go. And whereas in business, I think sometimes it's, if we miss that date, it's fine. It's often not catastrophic to the business. And I think that finding a way to push that sense of urgency in a context where it isn't necessarily naturally existing is quite a powerful thing, because it really does drive ruthless prioritization and making sure you're doing the most important things. That was a bit of a long-winded answer, but
no, it is fascinating. Do you ever watch America's Cup? Have you?
I mean, I've seen it on TV.
You're aware that it's a thing.
I'm not a huge sports guy,
That's all right. We won't hold it against you.
I was actually interested, because I know in Formula One there are really strict rules about communication between the car and the crew, right? Because they don't want it to be just robots driving cars around with humans happening to be sitting in them. And so, I think they don't allow any incoming telemetry to the car at all on Formula One. They're allowed to record stuff, but they still hold up signboards as they drive past, because that's the communication they're allowed to the car. So I was wondering, what are the limits in terms of during race time, the communication to the crew? Are you giving them weather information, specific, throw this control at this specific time, or
Yeah, great question. Similar restrictions. So there's a pre-start sequence before the race actually starts, and then I might be getting the specifics wrong, but at say 5 minutes before the actual gun goes off and the race starts, all communication onto the boat, onto the racing yacht, has to cease. So typically you have a chase boat that's attached to it, because that boat doesn't have a motor or anything. It has the sails, but that's it. So the power boat will be attached and kind of keep it in the right spot in the start box, and there will be a coach on board. The coach is usually receiving the weather information, but sometimes, and if we look back past just the Cup in Auckland, there were weather people who would go on the boat. There are famous stories in kind of the 80s time frame where you'd have 2 or 3 different people on the boat with old school Panasonic tough books, literally with life rings on, and at 5 minutes they would jump off the back.
Oh, right, yeah.
Because that was the best way to kind of get the live data to the crew, and then another chase boat would just come and pick them up.
Yeah. Burning 3 tough books every time.
The other interesting facet was there was a centralized computer system that all the boats, that was managed by the event authority, essentially by Team New Zealand. And so all the boats' telemetry would feed into that. And there was certain, and this is where I was highly involved, is only certain things could be connected to certain networks. And that managed all of that. And then the specific networks that would feed the computer systems had a randomized delay in it. And the point of that was so that you couldn't develop computerized like autopilot systems. So it wasn't just the robots driving the boat.
Yeah.
And so there was somewhere between a half second to a second and a half like delay that they'd introduce in the numbers, so that if you were trying to program an algorithm for, you know, mast rotation or foil flap and things like that, that you'd be too late by the time the wind shifted or things changed, and the boat wouldn't sail very well. To make sure that the humans were actually in the loop.
Hey, how big is the like the tech team versus the physical team on a boat?
Yeah, we had the sailing team, and that cycle, it changes a bit from cycle to cycle, but I think the sailing team all up was around 15-ish people. There were 11 on the boat when it was actually racing, so then there were a few spares, so to speak, or alternates. The design team is like 100 people in total, give or take, and the design team was 50 of that.
Wow.
So you had a team, like you had a team for the hull itself, you had a team for the mast, you had a team for the mechatronics, which is where like I sat. There was a team for all the hydraulic systems. So you had a team for the actual carbon mast bit, and then you also had sails, and like those were two separate teams. So, and each of those had 4 or 5 people, depending. And then you had like the simulator team. So we certainly, at least when I was on the team, not as advanced as what I imagine is in like F1, but we had a simulator that the sailing team would use regularly to practice maneuvers and test new boat designs and things like that. So yeah, somewhere in that ballpark.
Wow, that's massive. And
Well,
like
they're making something that, like, you don't really use a lot of the stuff you're inventing for anything else except America's Cup, right? Like, I imagine some of it will trickle down to more simple yachts, but the need for a hyperspeed foiling a sailboat is America's Cup, and that's it. So it's very one of one.
until there is another need.
Yeah.
I mean, it could be a really efficient way to get from Pacific Island to Pacific Island when we decide that the carbon in planes isn't worth it.
Yeah. I mean, one of those things I think would be cool if I was even slightly more sporty are those little electric hydrofoiling surfboard things. Have you seen those?
Yeah.
And so like the physics of foiling and the math around it, I'm sure, is like at least partly sponsored by the work that's gone into stuff like this, but then it trickles down into consumer toys like that. So.
I mean, you say a good, the word sponsor makes my brain just like pair together something that I can't believe I've never thought about before. Like, of course, this is why major tech companies around the world invest and sponsor these boats, Oracle, SAP, like, for a lot of people, that's where those names became household names. It's like on the sail of a boat. Did you grow up sailing?
Not really. I mean, being in Michigan, Great Lakes, like a lot of water. The doctor my mom worked for had a cruising boat that I went out on a handful of times, but I kind of picked it up randomly at college. Was home for the summer, looking for something to do, couldn't find like a softball team or soccer team or something to like keep me busy. And the America's Cup was kind of spooling up, and they had it on one of the like second or third tier TV networks in the US. And I was like, oh, that looks kind of interesting. And so just kind of randomly found a boat at the local yacht club and was like, I know nothing, but like would be interested to go racing. So,
because then like it doesn't feel like a job that people land in by accident. What did you study or pick up, or like, because with so much interesting tech and hardware and software and the way in which your brain must have to think to consider the type of work you do, was it always an interest of yours, like technology and systems, and were you always fiddling with stuff in the house and fixing the internet?
Yeah, great question. I definitely always like fiddling with stuff. Like I remember when we first got a computer when I was 9 or 10 or something like that, pre-internet age, and within like the first week I had it was a DOS based old 386 PC, and I went into the root file system and deleted the boot INI folder and broke the whole thing. Like, had no clue what I was doing, but I was like, oh, this file, I wonder what that's there for. Delete. Oh, it doesn't work anymore. That's a problem. So my dad was a machinist, and like I was always working with my hands, fixing cars, like fixing stuff around the house. Was actually very torn between mechanical engineering and computer engineering, which is what I studied at school. But yeah, always like just tearing stuff apart. How does this work? One of my favorite things to do now is like go tour somebody's like factory or something, because it's always just fascinating to me, like, how did you decide to make this widget? Because there's 1,000 ways to solve that problem, right? And I think there's really some unique and novel solutions out there where you're just like, oh, that's so clever. So really enjoy like doing that type of thing. But there was another part to the question that I've now forgotten.
That's fine. I mean, it's winding, and it reminds me, I think you and I have had the same conversation. I love seeing the story of engineering minds repeat over time. It's like, well, I was a kid who liked tinkering, and often with a mum or dad who had a machine-based thing. Because did your dad do something with cars or computers or?
He's a secondary school teacher, but he he bought our first computers because he was really into computers, and he now does stuff with computers as well. So he it was always an interest of his. I'm like, I like the physical world stuff, but I'm way too OCD, and so I have to really get like, I just bought a drop saw so I could cut some aluminium, and I had to be really mentally prepared because you just end up with tiny little aluminium chips going everywhere, and so I've got to be like, I've got to organize all of the cleanup stages.
Oh, wow.
Because otherwise, like, if I'm covered in aluminium dust and the thing I need to get rid of the aluminium dust is in on the other side of another room, I then have to now clean the whole room I've passed through to go and get that thing because I've gone through there with aluminium dust.
This is why people need workshops.
Yeah. So yeah, like, occasionally I'll look at like expensive engineering, like milling machines and things on Trade Me, but they're always covered in like metal dust that's been absorbed into the oil they cover the machines with. And I'm just I know I could not mentally handle. And so, like, in terms of like, how do I solve problems? I'm always looking for the problem that's the cleanest way to make something. It's why I like 3D printing, because there's very little, and the mess that it produces. I mean, there's a few toxic gases that you have to worry about, but otherwise it's all very inert. So you just suck it up with a vacuum cleaner.
Oh, that's actually quite funny. It makes a lot of sense. Do you have like fancy tech at home to play with stuff physically? Like, do you kind of have that need outside of work as your hobby to do like a physical thing?
Yeah, although that's mostly just come through in terms of home reno. Like right now we're I'm getting to the pointy end of redoing the kitchen. So that's been quite a fun journey. I don't know that I have anything specialized. Like, we have some 3D printers at work that I mess around with that keeps me from having to buy my own, which I'm sure my wife is a fan of. And like, I do have a little bit of a shop in the garage, like a drop saw and workbench and that kind of thing. But
did you get to use the fancy tools when you were working on the America's Cup boat? Like a carbon fiber autoclave would be pretty high on my list.
What's an autoclave?
Pressurized vessel. So when you cure the carbon, you fill it with 100 psi roughly of again, pounds per square inch. So I don't know what that would be in bar. 10. I think it's just drop one number. 10 bar, so that you smush the layers together. Because it's really important that you don't get voids, because air bubbles are like where the failures will occur typically.
Right.
So before the America's Cup, I ran a carbon mass builder in Detroit.
Right.
So, which is it was more a networking thing. Like one of the college professors, who wasn't actually my professor. So full job history. I started in my school had a hydrodynamics lab.
Wow.
And so we had
by school you mean university?
Yep. Yeah. So we had a roughly 100-meter tow tank. So there was basically this, if you imagine, kind of like a really maybe 5-meter wide bridge. That you could stand on and ride on, and then sat over top of a straight pool of water. And so we would suspend boat models in that and drag it through the water and do hull resistance testing, wave making resistance, and measure a bunch of stuff. And then so I did that for a few years. From there, jumped into automotive manufacturing for a bit. I didn't really like that so much, and then went to this mass builder in Detroit. And so the professor that I knew from the naval architecture department, who I had done a bit of sailing with, was friends with one of the higher up guys at American Magic, and so that's sort of how I got the interview. But I'm imagining they liked a bit that I was already in the industry. Can't say for sure, but yeah. So we had a like 50 meter autoclave that we made mass with. So I'm sure this is subconsciously happening, but I've always tried to be, the jobs that I find most interesting are the ones where there are like unique and fun tools that I can experiment with a bit outside of like the actual job.
Yeah.
I always get jealous of people on YouTube and they're working at a job and they've got like a fancy 6-axis CNC mill. It's like, oh, I needed this piece, so I just went and used the $80 million machine that costs $1,000 to run to make my little $4 widget.
Yeah. As a marketer, I suppose there aren't specifically the same type of thing. However, if I was working at some type of factory like that, I'd be the person going, can I start a whole reel series about like squashing stuff in a hydraulic press? And that would be my favorite job because I love watching those videos.
And then you'd be independently YouTube wealthy. And
I would. I mean, it's funny what captures people's attention as like tiny little pathways into understanding. And so here's a sideways jump from boating into farming that you'll find interesting. So if hydraulic press is my social kind of fodder for factory stuff, I also really like, and don't judge me for this, I'm not alone, videos of people of like professional hoof cleaners.
Yes.
I hate them.
Oh my god, they're amazing. Yeah, this is just like so anti all of your like, it's not, it is like the dirtiest possible thing. But like going into a farm environment, the engineering mind, it almost like goes backwards a step because there's so much old stuff.
Yeah.
And I've spent a lot of time in farms. I have lots of family farms, and some of the loveliness about a farm is its rich history. But then you guys are so on the tech side of it. But yeah, that's like just how they get the thing up, and then the tools, and it's so physical. But ultimately, you guys have a very tech way into farming. That's like my sideways jump. From boating to farming.
It's quite a speed shift. Cows are famously slower than...
like circle face.
Yeah.
How much control in like motion do you have? Like, is it just like a tingle that tells them go to the... Like, is it just a one-off go to the shed and come back out to the farm? Or can you specifically steer them by like little haptic vibrations?
Yeah, I mean, the most important, like the reason the system works well is because we're just reinforcing the animal's natural patterns. Like we're not trying to make them do anything they wouldn't already want to do or be inclined to do. So the primary cue is sound. And so, yeah, we have a speaker on either side and can use that to indicate to the cow, like, hey, yeah, like it's milking time. You know this, you do this every day. But like now is the time, and like you should start moving towards the milk shed. And also as herd animals, kind of the first one that goes, they all follow.
It's a shame. I was just hoping you could sort of use it to drive them towards, like if they drop out of signal, you can just use the collar to drive them towards a higher signal area of the field. Just like have them do a search pattern until they get signal back, and then.
Yeah, well, luckily the signal, I think we probably optimize more for making sure the signal's good in all parts of the field, and so don't have to try to go to that extreme to ensure that the cow gets the command to go to the milk shed.
Yeah. Just for context, I guess, Halter does a collar for cows specifically.
Yep. I've been A/B testing a bunch of different lines on this, but the real quick explainer I've used is that it's an Apple Watch for cows. So it's a solar powered device that sits around their neck, and with that, like I said, it has sound cues on it that we can use to indicate to the cow, hey, it's time for milking, or if milking's finished, hey, time to go back to the paddock. And then we also can monitor their behavior. So detect whether they're lame or whether they have mastitis or a few different health issues, and also look for like reproductive heat. So, which is obviously important to dairy. We also have a beef product that does similar things, like slight nuances between the two, but generally, the main thing that it unlocks is there's a huge time saving component. So it sounds like you have some experience with farming, but New Zealand's a pastoral system already, world leading pastoral system, and so it was a great spot for the company to start. One of the most time consuming things is that to do I guess grass farming really well is you have to be very precise in the allocation of grass that you give and make sure you're like shifting the cows a lot, is like the real short summary. And so what that means in a non-halter world is that you have electric tapes and sticks that you're putting in the ground and putting electric tapes up and doing that several times a day. And depending on how big it is and how many cows and all that kind of thing, you're spending half of your working day just like moving these sticks and electric tape around. And so we give you the ability to do that even better than that precise allocation, because you can draw any break shape you want with our technology. And so you want to fence in some like weird corner of your farm that's like kind of over some rocky outcropping or something. Like there's no mandate that the stick has to be able to grow in the ground. Oftentimes, because it's sticks and tape, they do straight lines because that's just easy. But easy often means you're compromising on that precise allocation piece. So then we also tie in satellite measurements and a predictive growth model for the grass itself. So we kind of we bring the two lines together of grass growth and like how much food do you have for the cows on farm against like how much are you giving them on a day-to-day basis and how much are they eating, and allow you to really precisely make sure the cows are getting the amount that they need at the time of year, because their resource needs are different depending on whether they're milking or have just calved or doing these different things.
So this is actually way more intensive about the health of the cow or the feeding of the cow than just like invisible fencing.
Yeah.
So correct me if I'm wrong, because my primary exposure to dairy was when I was maybe 10, and my uncle owned a dairy farm and my father looked after it for a week, and he would just go out every morning upset and then come in every morning covered in cow shit. So I don't have but I know that like part of the issue with grass allocation is you're trying to meet like a minimum like dairy fat content in the milk or something, right? So like, are you tying in measurements from the milking side back, like as a closed loop system where you're measuring like the outputs and then adjusting the right?
Yep. So we integrate with Fonterra and Synlat and the milk, not milk producers, the milk distributors, I guess.
Yeah.
So every day the farmer gets a slip of paper that says, here's how much milk was in your vat, and here's the fat content, and basically like how much are we paying you for what you've produced today. Yeah. So we have an integration that automatically pulls all that data in from Fonterra, and so that like completes the feedback loop. And you're absolutely right that you're kind of trying to hit this minimum allocation, but it's quite a tricky thing because you also have to make sure that, because it's very easy to overgraze for a few days and then you wind up shorting yourself a couple of weeks later because you've gone too fast. Right. So you're always trying to like match grass growth against how much your cows are eating, and at the same time trying to make sure that you're producing sort of the maximal amount of milk. And if you don't feed them enough, they can also like, because it's basically a bell curve, like after they calve, they increasingly produce milk, and then over time that kind of tapers off. The like peak of that graph, that roughly, or like the biggest correlation is to how much grass they're given. So if you short them on feed kind of midway through that cycle, the peak won't be as high and they start tapering off more quickly. So ultimately that's just money that the farm isn't generating because you've inaccurately like allocated the feed. So a couple different ways you can solve that. Like if you've gone too fast or over allocated, you can buy in feed, and that's fine, and then that will generate the milk, but then you've paid for that. Whereas grass is free in the context of it's already on your farm. You just need to manage it as well as you can.
Well, they spend. I mean, I don't know. I assume there's lots of ads for like fancy grass seed and fertilizer and other things for grass that I see on YouTube. So I assume that like the cost they spend on managing the grass is relatively high too,
What are
right?
you
Like they're not
looking
just
at
using.
that you've slipped into the algorithm of
Don't
farm?
don't look
Farm
at my
and talk.
Yeah. I will get in sequence a doll for 6-year-old girls, and then a super yacht that's going to be like more than $50 million, and then a laser welding cleaner, and then a grass that happens to grow slightly later in the season. And the algorithm has no idea.
They
who I
don't
am.
know who you are, so they're just throwing stuff at you to see what sticks.
I'm surprised maybe like cleaning, really good like cleaning products have come up in that algorithm anyway.
Nah, I mean
some fancy Dyson thing that like
the laser cleaner. There is a satisfaction of watching rust disappear off a rusty surface.
Yeah.
I mean, I know that like the little, again going back to how little I know about farming. We talked to one of the large farming research investment organizations a few years ago. And they were talking about like the number of milk days that you get off a cow, and how New Zealand is a leader in the number of milk days, to the point of like they'll ship cows around to farms if they need to maintain that grass input to keep the cow milking for as long as possible. And so there were a few metrics where we were world leading in terms of the effectiveness of our process. But some of that could be the environment, right? Like New Zealand has a lot of water, and that's one of the main inputs to grass. So.
Yeah.
Yeah.
And to the cow itself.
Right.
They obviously they get some water out of the grass, but they also need to drink a fair bit. And that's what we launched in the US over a year ago, but kind of have really been investing there a lot recently. And like that's one of the interesting like second order effects of getting Halter in those environments is what we've unlocked is like now you can graze however you want. And for in the US it's for most farmers and ranchers a much bigger step change because they're used to having a 500 hectare piece of land that they just put all the cows on for a month or whatever the time frame is, and the cows just kind of do what the cows are going to do, and then they go out there on horses and round them up a month later, and so there will be water excess in there somewhere, and so the cows just kind of work that out and they take care of themselves. The rotational grazing aspect that we now allow them to do in an area where it was just infeasible to fence before. Now you're like, okay, cool. Now I can move them around and do this precise allocation, but I don't have water in all those spots. And so you like now people are totally rethinking how they're farming with respect to like, okay, I was going to invest in XYZ. Now with Halter, it's like, well, really my biggest constraint is water. Like if I can get water in the areas that I want to be grazing, I'm like totally unconstrained in how I like manage my farm and manage the grass. So it's just quite an interesting like how the problem shifts when you provide a tool that does something that they've never been able to do before. Yeah.
So what is in 5 years at Halter, that's enough time to see quite a change in the way that farmers do business. What's like, in thinking back to that kind of human in the loop thing, there are very physical, tangible things that farmers have to be in touch with. And there's also, I think, a really human, emotive, traditional provenance. A lot of people are on farms that have been in their families for generations, so that aspect is always there. But what's the change for what a modern farmer needs to be across? Or like from a tech angle, do they just quite happily outsource what they need to you guys, or is there quite a learning curve tech-wise?
Yep, great question. I think there is a learning curve. Like it's certainly a fundamental shift in like how you're running your business. But that said, the things that we allow them to do is not anything that they weren't accustomed to before. So all the things that we care about and we visualize for them in a really easy to understand way and like put the data at their fingertips, we're essentially trying to give them the ability to make really well-informed decisions very rapidly and then unlock the ability to then act out those decisions on farm in such a way as to maximize output productivity. So the farmers have always cared about grass lengths, and like the best farmers would do daily farm walks and like measure all the grass in their farm and know that you have a mental image of their entire farm and know I have exactly this much grass in all these spots. And, either on a piece of paper or a whiteboard or just in their head work out like based on time of year, what's my round length, meaning like if I'm grazing at this speed, how long will it take me to get from beginning to end? And what that means for the farm. And so instead of forcing them to like try to work all that out, we're measuring the grass for them. We're calculating the round length for them. And so then they can spend time. So between doing those, like working that stuff out and moving electric fences around, that pretty much consumed all of your day. And so while they still are looking at our data, and because we're not making the decision for them, we don't tell them slow down how much you're feeding or speed it up or anything like that. We're just saying at this rate, here's like what your round length would be, or at this rate, here's XYZ. It allows them to think about, okay, well, if we have a really bad patch of weather, what's that going to mean? And should I be taking any proactive measures now to like account for that as we head into winter, for instance? Or, spending more time with the actual animals and looking for things that don't seem quite right, or just like more like face-to-face interaction.
Yeah. more time for their YouTube channels and social media brand building.
Yeah. I mean, there must be kind of part of, and maybe Halter's kind of benefited in some way from being in the cusp of time where farms are either have moved or are moving from a slightly more non-tech generation. And again, my mind goes back to my partner's father still running at 85 or something, his 100-year-old farm, won't even use a phone to pay for stuff, doesn't like tech, full stop. And he will never be the kind of customer that Halter could capture. But a farm like that is going to move. And when Francis was on, we were talking about the great wealth transfer as one thing from boomers to Gen X and millennials. So you kind of capture this market of farm owners who are probably more tech savvy than the previous owners anyway. They're kind of ready for that.
Although I think that there's been a reasonable transition over the last 20, 30 years to more corporate-owned farms and less owner-run farms, right? Like there are still plenty of owner-run farms in New Zealand, but there are more and more farms where the person on the farm is the farm manager who's managing it for an investment body, rather than running it for themselves.
Yeah. I mean, there were some really hard farming years. I'm thinking back maybe 10 years where the dairy price went down so much and a lot of farm owners just had to sell up. And that's probably the economics of farming that can't be solved by.
I mean, it's the same problem as, I'm going to get on my favorite grind and rail on capitalism for a while. Yeah. It's the same problem you have in any industry, right? Like as you scale up, you get the benefits of economies of scale that you don't have as a smaller independent, right? So you have the ability to move cows between multiple places in the country because you have multiple farms that you can move them to, and you can collect data and put them at where is optimal rather than, well, I've got this field, so that's where they're going, whether it's optimal or not. So I think like farming is not immune from the tendency of capitalism to form larger organizations.
I mean, maybe it's the most at the mercy of Mother Nature and the elements, and it's almost like you're trying to optimize and control as much as possible whilst battling elements that are 100% out of your control. And that's a kind of, I don't know, what does that tension feel like? Because it's really, you could do all of the planning that you like and put in all of the systems, and one natural event could completely derail or change. And I don't know, that feels humbling, but it must be frustrating.
Yeah, well, I mean, we kind of quite famously put a massive hole in the side of our boat due to a weather event, then almost sunk it to the bottom of the Hauraki Gulf. So yeah, I think ultimately you're doing all the things that you know how to do to set yourself up for success in the scenarios you can control for.
Yeah.
So I wasn't a sailor on a boat. Like that piece of it was out of my control, but I was going to make sure that though they had the information that they needed when they needed it, that everything worked 100% on the day. Same is true for Halter. It's obviously a less like race day centric thing. It's just every day the system has to work, to kind of some comments you made before about uptime.
Did you have a guy on the boat that was was the delegated IT person? So if a component failed, that was just
there's no set
time.
number of people, and like there would be no time. Like if something failed, like by the time even in the quickest scenario, by the time you'd be able to fix it, the race would be over. They only lasted 20 to 25 minutes.
Because also, like, you're thinking about the weight of the humans on the boat, right? Like, even the grinders and stuff get so big, and it's like, you have to stay within a very specific weight threshold to be allowed to be on the boat, because you have to take up this much weight, which means this guy here has to stay under this weight.
Yeah, everything got weighed. There was a very strict, I don't remember the exact numbers, but there was a total weight for the crew, and then each person was like plus or minus a couple.
Wow.
For just like, I think, water weight variance and stuff.
Yeah.
But it was like very, very tightly managed. All aspects of the boat were weighed because you had to meet a certain criteria and individual components. And like, it was all very, very highly regimented.
100% tech working. That's high stakes though. Like,
I mean, I was just
that
thinking,
can't
like,
be possible all of the time.
well, that's like they've only got one mast, right? They've only got
Yeah.
2 foils, but they don't have any spares of anything else.
Yeah.
So I guess it makes sense you don't have any spares of any of the technology either, right? Like the part of the point is to try and build stuff to be as reliable as possible with just the one of everything.
Yeah.
Actually, the opposite was true.
Oh, yeah?
So when we almost sank the boat,
Yeah.
we had an entire set of spares for all the electronics in the boat.
Oh, wow.
And that was probably the only reason we were able to go sailing again. Or like, obviously, the boat builder said everybody put in a massive shift to get it back on the course. But we were joking in the tent afterward that like the boat building part was kind of the easier part, because that was very well defined. It was like, lay up this piece, put it in there, like that we know how to do. We had considered the possibility that everything in the boat failed, and so we had spares, but you never really thought that was going to occur.
Yeah.
I'm surprised you'd allocate the weight budget to it, right? Like if you're measuring per person.
Well, they weren't on the boat.
Oh, right.
In our container.
Right.
Like they were just ready. And the intention was like, if any singular one of them failed, you had it ready to go off the shelf.
Yeah.
We did not expect to be replacing the entire boat in mass. Yeah. Actually, the one thing we didn't have was a full set of cabling to go in between all of the computers, essentially, and sensors, because it was very like special cable with special soldered ends. And so we didn't have a full set of spares for that. So it was so we replaced all the computers, all the sensors, all of that. And then I literally was going through every single cable and connecting it and checking it to make sure it worked and cleaning it out and just trying to like do the best we could to ensure that the cable didn't fail while we were racing.
Yeah.
But yeah, it was like funny that Ethernet wire, like special Ethernet wire, is what ultimately is the thing where you're like, oh, that's what we don't have.
Yeah.
Another like 2 miles of, or whatever the total amount of wire was in the boat.
It reminds me, quite a big segue, but watching a YouTube video of a guy doing a data center layout design for NVIDIA, like for AI inference. And he was saying they went in and the racks were 30 centimeters more spaced apart than they needed to be. And because of the cost of the cable, because they use really expensive InfiniBand cable to connect all of the things, was something like $10 million extra for those computers because of the 30 centimeter extra gap that they didn't need. And just squeezing them all up saved them a ridiculous amount of money on cable. The thing you don't even think of most
Speaking
of the time.
economies of scale.
Yeah.
When I saw this photo of you sitting on the ground with a laptop, like, I don't know what level of stress was behind that photo. But that's really what
maximum level of stress. That was after the crash. That's when I was testing everything to like put it back in the boat.
Because zero fail, and like to be responsible for things working across an entire system when the elements are against you. I suppose, is there anything? Well, the crash is probably, I was going to say, what's a really interesting, like, not necessarily failure story, but when can you just say, I can't guarantee 100% here. It's acts of God. It's Are you ever in a situation where everything looks like it's all connected and it should be going, and you're just like shaking all the elements going, this should be working? This was me at home yesterday with my Wi-Fi going, I don't know why it keeps dropping out. Everything points to working. Like, where do you start going to get it fixed? Or do you just sometimes have to walk away and go, this can't be fixed and I don't know why? It's a gremlin.
I mean, quite frankly, in that scenario, like, that's not an acceptable answer. So, I guess I do have a story about that where I had recently upgraded some stuff in one of the chase boats. We were out for a training day, and the network back to the boat was like flaking in and out. So the numbers were just like dropping in, coming out, and I was tearing my hair out, like, and ultimately I just wound up like stepping through each individual. So I started with the things that I suspected would be the problem, a burned out component, some like software service not running correctly, like restarting stuff, checking the metrics I could see, trying to figure it out, and running over it. And then I was like, all right, just have to work front to back. And so just started at the computer in the boat, worked all the way back. And what had happened was somebody had been in messing around with something adjacent to a component I had installed, and somehow I think they had loosened the coax connector. It was like an amplifier for the radio, and that was like just kind of like sitting on top of the connector, so it was like bouncing around as the boat was bouncing around, so it would like connect, and then we'd hit a big wave and it would kind of like pop off. And so I don't know, that took me an hour or 90 minutes or something like that to kind of work that all out. And then I screwed it back down, and then everything was fine. And like, but there was a lot of stress of like, I had 10 engineers being like, we can't do training. Like, the boat's not receiving the commands. We can't do the things, like, what's going on? And I mean, at the time I was just like, I'm not sure, like, I need some time, but I'm working on it. And ultimately figured it out. But I think it's those problems can easily become sort of intractable, and the best thing you can do in those scenarios is break it down into small chunks and just and work through it methodically. Like, it doesn't necessarily have to be in a linear order. Like, I sort of jumped around a bit. I started with, well, here's what I think might be wrong. Okay, that wasn't it. I sort of ran out of like likely suspects, and then I was like, all right, well, now I'm at the point where I just got to work front to back and then go in that kind of linear fashion. But I think, maybe there's a point at which you do all of those things and still can't figure out what it is. But I imagine you just keep iterating on that loop. And like, I've never found myself in a scenario where I've just gone, I can't figure it out, and I'm not going to figure it out, and I like give up.
The conversation's usually more like, I can't figure this out and it's not worth the investment. Like, the cost of this issue is not worth the investment we would need to put in to fix it, right? Like, to your Wi-Fi example, you probably didn't even consider, well, the easiest way to solve this is throw all my Wi-Fi gear out and replace it with new Wi-Fi gear. Right? Like, that's a really fast way to solve that problem. Like, you just replace everything. And depending on your budget envelope, that might be the best solution, right? But like, we occasionally have spots in the office that have poor Wi-Fi, right? We kind of know why that is. It's because the signal strength from an access point is reasonably predictable, but it doesn't match with your building. We didn't build the building to have perfectly even signal strength everywhere. And so there's no optimal layout of access points where you have just the right strength, not too much, because too much means you can't, the computers can't talk to the access point because the access points are shouting over each other so loudly that the computer can't produce enough power, and not so far apart that you end up with dead spots. So we've just got some spots where the signal is not as good as it could be, right? Now, the solve to that is build your building in a way that signal strength is super consistent across the whole building. But that's like, we've just gone, well, it doesn't actually stop us from using the laptops, right? Like, it just means the signal strength is not optimal somewhere. But that's like, when you get into systems design, it's like, well, it is critical for the signal strength to be everywhere. So that's one of the inputs we need to go into designing the shape of the thing we're building, right? Or we can't use Wi-Fi off the shelf because it doesn't have the ability to wave shape the signal. So we need to go to something which can be aware of where all the other access points are, so that they can shape their emission pattern so that they don't end up with these overloud areas of signal. There's lots of things you can do. We just look at the problem and go, It's kind of annoying, but not annoying enough to be worth
It's
the cost
easier
of
to
solving.
tell that human to move their laptop over to this corner. Which is a home problem too.
It's one of the issues with security and encryption, right? Like there's a type of attack for encryption called rubber hose decryption, which is where I go and beat someone with a rubber hose until they tell me what the password is. Right? So the human in the loop is often the weak point in security, right? So.
Yeah. Well, it's interesting because as you're talking, like I'm thinking so much about diagnostics, and it kind of parallels, like, say, a doctor. You are given a set of symptoms and you're methodically trying to diagnose and eliminate problems to find the cause. But interestingly, now we're saying that for a set of human physical symptoms, actually AI might be a better doctor a diagnostic doctor. But the cool thing about your job or in both, say, the boating, the America's Cup example, and in a Halter example, you need a really good blend of physical, mechanical engineering type thinking, as well as the software type engineering. And so I'm wondering, like, as you build out a team, as you hire people, or as you look for people that I don't know how big your team is in particular, but you kind of need that dual set of skills, right? Is that fair to say? And like, as engineering and jobs start to mesh over the AI era and start to blend, a combo of a physical world engineer who has software engineering capabilities feels like a really tight glue. Yes?
Yes. I mean, I don't know. Like, you probably
What
have.
is your team like?
Yeah.
The team, Halter's still relatively small. We're in around about 200 people like total. So my team's 8. And we believe in smaller teams, move quicker, that kind of engineering management mantra, or I guess just general management mantra. So I think there's like a natural move towards, as companies grow, the scope of a role becomes much narrower because you can get domain expertise. Like right now, we don't have a person whose sole, I guess, experience and background and job is like optimizing for wireless transmission patterns. I have some knowledge in the area. We have a couple other guys on the team that are knowledgeable in the area, but none of us did a PhD in it or like that. Nobody like designed RF communication systems as their like kind of entire career path. But there's also other problems to solve that aren't just necessarily that, but that, we maybe are getting to a point where we would hire that role because like, our size is now such that you'd see a benefit relative to what it costs to hire that person at, 500,000, million, 2 million, 4 million devices. So yeah. And I think the AI piece is interesting. Like I view it as a tool like anything else. I think those people that know how to use it well and use it are made much more efficient, similar to Halter in a way where it's like a farmer who knows how to use Halter really well can get a lot out of their farm. An engineer or just anyone in general who knows how to use AI well can really like speed up the work that they do and probably like lift the quality of that work to some degree. Like I'm not particularly good with grammar and like speaking, and like I use ChatGPT all the time. Be like, I write out 500 words and I'm like, make this 50. And it's like, cool, here you go. And it's like, man, that sounds so much better than what I put down. Like that's probably one of my main use cases for that. So, and I could spend an hour dissecting that paragraph down and trying to distill it down, and it does it in 10 seconds, less than that. So, I think the physical connection piece is probably, I think Halter would generally tend, like we would excite people who are driven by the mission and being connected to the physical world. I don't know that you necessarily need that like blend of kind of mechanical and computer skill that I have some background in necessarily, but we also do have a lot of people that look like that. So while we're not necessarily like specifically recruiting for that, I think that kind of comes through in the product that we have and the customers that we support. And like, if that's a thing that excites you and like interests you, is like, yeah, like I can go to the farm, like our founder, Craig, grew up on a dairy farm in Morrinsville. Like that's our kind of R&D farm, we have a company mandate of everybody getting out into the field at least once a quarter, trying to talk to customers, like viewing the product in action. And Pete Beck came and talked a while ago, and he's like, when somebody's having a really tough day, it's like we tell them to go rub the rocket, like run down to the shop and like put your hand on it. And that's kind of our version. I don't know if we have a like slick tagline for it, but it's like go kind of pet the cows, right? Like
touch grass.
Like, exactly. Actually, I think Craig might have used that one, touch grass. I can't remember now. But yeah, similar thing where that physical connected element kind of reminds you why you're there, and you don't necessarily have that in, I guess, your prototypical SaaS business. It's pretty tough to touch the dashboard.
Yeah, I mean, it's definitely like there's a psychological thing you have to get. I'm going to go on a wild tangent, actually.
Love a tangent.
I forget who. There was an art master, and at the time, to become an artist, you would go and work at the studio or the gallery of an art master, and he would initially have you paint a bunch of paintings, and then if they were good enough, he'd sign his name to them. There was a whole commercial thing going on, right? But one of them, I think it was Warhol, just because of the commercialism of it, right? Like what they would do is when they got their first painting that they were really proud of, he would say, okay, now burn it. Right? Because you can't survive as a commercial artist if you're going to hold on to all of your work. Your job is to sell these.
Yeah.
If you're too attached to your work, you aren't going to be able to make a living from doing it. You can still do it as a hobby, but it's not something you can do commercially. And I tell that to the engineers sometimes, because a lot of what we do is extremely ephemeral, right? Ultimately, we are organizing electron spin into patterns that we find useful, right? Like it's an incredibly delicate thing that we're doing. Not in terms of the work, but in terms of how easy it is to lose that, right? Like, removing the boot INI file. These you can put 10 years of your life into something, and then 30 seconds of error will remove the whole thing if you're not careful about your backup. And even in the best case, like the stuff that we do is only appropriate while that business need lasts, right? Like, we probably need dairy for a while, right? But like a lot of the websites that we've built for desktop, like the need for that is dropping off as people have moved to mobile interfaces. It's like that's still a thing that has some value, but over time the value is reducing. It's going to go away. So don't get too attached to the work that you do. Be attached in the moment. Be attached to the value you're producing now. But you're not Ozymandias. You're not building a statue that's going to last through the ages and be your legacy. This is something for the now, not something for the long term. It needs to last exactly as long as the demand for it exists, and then it basically doesn't matter after that whether it goes away.
I mean, you can go really philosophical there and go, it's about separating your ego as a person from the job that you're doing, and there's some pride, I guess, in doing a good job, putting your work out into the world. But if you are so closely aligned, your identity, to the work you do, then you don't have the ability to be resilient or say, like, pick yourself back up and start diagnosing problems when your boat has a hole in the side of it. If you crumble under that type of pressure and think, it was all me, what did I do? My system should have worked. Then you don't progress quickly into that problem-solving mindset.
And there is... there's an environmental benefit to it. Like the reason I got into computer science, my grandfather did electronics. Like that could have been a path I went down as the physically, I would have had a hard time with my OCD, but it could have been a path we went down. But we didn't really have the money to, but like, when you do electronics, you need loads of little transistors and resistors. And at the time there wasn't element 14 where you just order stuff and it would arrive from London the next day for no delivery fee, right? That was incredibly expensive to experiment and play and try stuff. Whereas with programming, like there's no environmental cost to throwing the stuff you make away, right? So compared to like if I was a factory clothing worker where I was making, my job was making t-shirts, I think I'd find it really difficult to then see stories on the news of the t-shirt that I'd worked, just spent the last year manufacturing just in huge piles in some rubbish thing, somewhere causing some sort of environmental waste.
Yeah.
Like, not only is no one found value in my work, it's actually negative value. It's impacting the environment. So it has that benefit, but it's not tangible at all, right? Like you can't, like you say, you can't hold the thing and say, this is the thing that I made with my effort.
Yeah.
Although the expanding on that a little bit, I think an interesting, with all the data centers in general, but especially like the AI data centers, and the amount of various agents and things that are now running, the amount of energy that's being consumed, but also the constraint on the GPU resource, essentially. I would be really interested to do a deep dive on how much inefficient code is running in those spaces, and like what kind of a lift, like would you unlock 20% of a data center's capacity just by virtue of like throwing away a bunch of stuff that's really inefficient?
I mean, definitely, possibly, right? Like, we don't do optimization much anymore. It's one of the reasons we've gotten cheaper to make software, right?
Yeah.
Like, when I was first writing stuff for the internet, you could have an engineer spend a couple of weeks trying to shave 200 bytes off a GIF, and that would be worthwhile because you could work out the bandwidth cost of those. Like Google did, they like the fav icon, they had the little icon that sits in the tab.
Yeah.
They worked out how many millions of dollars they saved by reducing the size of that because they were just sending it so often to so many people, and bandwidth was really expensive.
Yeah.
And as stuff's gotten cheaper, we've just the adage was always hardware is cheaper than developer time, so don't worry too much about optimizing it. But that is more true now than it ever was, right?
Yeah.
But AI poses a specific example, and I oscillate between being a bear or a bull on like AI futures.
Yeah.
But the strongest bull argument, I think, is the largest organizations in the world require it to be a success for their continued existence.
Yeah.
They have taken so much of their shareholder commitment and actual cash and invested it in AI hardware.
Too big to fail.
They need it to be a success. And so
Yeah.
they will make it be a success one way or another.
At the cost of the environment or anything else.
Yeah.
To what degree do you guys have to consider environmental initiatives, either CSR payback or to convince farmers? Like, what part of the Halter story is tied to the environment? Feel free to say, I don't know.
I'm just trying to frame, I guess, the answer. The food production is naturally like a environmental. It's very closely coupled to the environment, or like is the environment, I guess, is an argument you could weigh. So there's no way for Halter to exist without being involved in that to some degree. And there's, in New Zealand, there's legislation around waterway protection and things like that.
I was going to say, do you measure nitrogen runoff and things on the grass?
Yeah, so we don't specifically measure the runoff piece of it, but we're working closely with the customers, because ultimately the legislation comes from Parliament, and it's like, we're going to do a thing, and oftentimes that goes through industry groups to figure out, okay, how do we write this bill to kind of do all the things we want to do, and so we're to some degree involved in those discussions as it comes through to our customers, and trying to figure out how we can best help them meet some of those requirements. I'm not specifically across like a lot of the particulars in that space, but I do know that it's a conversation that's happening regularly, and ultimately it just comes back to making the farmers' lives easier and keeping them focused on the stuff that's most important to them. And so that's taking care of the animals, taking care of the land, like being efficient with their operation. And so worrying about whether or not their fence broke next to the river out back is like not something that adds value to their to their operation. Yeah. And so we're just trying to figure out how best we can like help support some of those environmental initiatives. And because obviously they're like, we want the planet to be a habitable, clean place, and like help as much as we can in that space.
Yeah.
My favorite grind.
Capitalism.
That was a deliberate PR attempt by I think the plastics company, but definitely by corporations, to push the responsibility for littering and for environmental damage on the individual. When it first started to become a thing, corporations were like, we are responsible for this. We are going to get in trouble. What do we do about it? What we need to do is we need to get everybody to individually think they are the problem and that the only way to fix it is for them to take action.
One of the worst things we could have done for the planet was that little triangle with the arrows going like this.
Really?
Well, in that exactly as you were saying, that you're pushing the responsibility down to the consumer and they're not taking responsibility for the trash that's being produced. It's like, oh, well, it's the end user's problem now.
Yeah.
And that just essentially abdicates them of any responsibility when that's not true. And definitely they had a lot of agency in trying to create a more sustainable plastics use system, but instead said, well, we'll make it somebody else's problem.
It's funny you say that. You wouldn't have been in New Zealand at the time, but as a kid of the 80s and 90s, you'd remember this. So New Zealand, there was a lot of money, time and effort put into New Zealand. Keep New Zealand Beautiful was the campaign, but there was a song and a jingle on the TV. And at some point, it's like, do the right thing, put the litter in the bin. I'm not going to say
Be a tidy Kiwi.
Be a tidy Kiwi. And at some point, it literally says littering's a sin. Yeah. and it really affected a whole generation of us, I swear. I still sing that jingle in my mind often. I'm aware of time, so I had like 2 really interesting questions to ask, and now I'm going to struggle to remember either of them. I am curious if I saw on the Halter website, there's like a lovely illustration. It's got like a cow, and it's like, here are our towers, and here's your phone. And the complication of that seemingly effortless and simple thing is, I imagine, where the bulk of your job lies. Yeah. And
how annoyed does that diagram make you when you look at it? To be like,
you're doing your job so well, and it's that simple for the user.
Well, yeah. I mean, I think ultimately the detail of that shouldn't and isn't relevant to the customer. I mean, a bunch of them are interested. They are engineers either in training or just like by virtue of being a farmer, and so there lots of our customers are interested in how we do it. Yeah. But at the end of the day, like if they have to understand the details of how that works to like know how to use the product or anything like that, like I've failed at my job. Yeah. It needs to be that simple for it to make sense, because also every one of your customers isn't going to be a tech-centric engineer type person. It's like it has to cater to everyone. So it needs to be as simplistic as like collar, tower, phone, like it just works. Yeah. TM.
And that's, I suppose, what intrigues me about that, like the ego part of it, or like the just the resilience part of it. If you're doing your job super well, nobody knows. And if something goes wrong, it's all your problem. And in there, you just have to be so satisfied being just like the orchestrator behind. Do you know what I mean?
I use the goalkeeper reference a lot as like for soccer or like ice hockey, where when they're doing a really good job, most of the time that you don't know it, because it's like they're just you're kind of, in a way, you're kind of always on the defensive, right? Like you're preventing the other team in that reference from getting points. Yeah. But you can't really score on your own. Like you can't be the offensive strategy. So a different way to put it in our case is like we're the enablement of the product to do the magical thing that it does, right? Like to unlock that transformative product and change the way that our customers are able to run and operate their farms. We're the layer that like links all the pieces together, and so that has to exist for the product to function. But we don't or my team is not responsible for creating the new like cow feature that totally changes the next stage of farming, or
makes me think of upgrading the actual cow.
Definitely don't mean that, but can we improve our monitoring of it? Like, can we give you really, really precise measurement of some aspect of your farm that you don't currently have that can change the game for you? We're like, that's not the part that I sit in. We certainly have those teams, and they do a great job, and they're the part that our farmers are looking at every day in the app. We're as similar to our hardware team who designs and builds the collars. It's like that has to exist. The hardware needs to be there, or else the whole thing doesn't work. Yeah. But yeah, you really only hear about it when it's not working.
Yeah. In your specific role, do you, without probably, selling billion-dollar secrets, what proportion of your time is spent doing like retroactive diagnostics versus like proactive optimization? Like, where are you spending most of your time? Are you trying to make things like incrementally better? Or are you just like, let's figure out why that thing didn't work the way it was supposed to?
Yeah, great question. It obviously ebbs and flows a bit, but I think me specifically, I probably would spend the majority of my time thinking what's weeks, months, potentially years down the road, and trying to like look ahead of what's the next thing we need to be doing. But there are like the system has to work, and it always has to work, and so we do commit a fair amount of time and resource to diving in on that 1 in a million type problem where it's like, oh, why didn't it do the thing?
Yeah.
Let's not have that happen again. And trying to go through those one by one. I mean, the interesting thing is like we're hitting a scale now where those types of really rare problems become less rare just by virtue of the number of devices you have out in the field. It's like, if it failed 1 in 1,000, well, that might have happened once a year 3 years ago, and now it's like once a week to make up some rough numbers. So you kind of are always there's always new stuff coming out of the woodwork, but it's probably always been there. It's just never, it happened so infrequently that, it's like, there's some interesting kind of papers and articles around Amazon and some of these other like hyperscalers where there's very few places in the world where you're doing like hundreds of billions of transactions a day and packets moving between various things. And so it's like, they're down to, I read one a while ago where it's like, they're down to the level of, you'd have singular bits flipping in RAM for like random reasons, like just entropy, I guess, and
cosmic rays, actually.
Yeah, well, it could be. Yeah. Neutrinos.
So there's two types of RAM you can buy. There's a regular RAM you have in your desktop, and there's ECC RAM that goes in the server. And ECC RAM has an extra piece of the RAM chip, which checks the value to make sure it's still the same as when they wrote it in. And the reason you have to do that is because there's rays that are shooting through all of us all the time, and sometimes it'll just change a piece of your memory.
Yeah.
I'm going to be thinking about that all day.
So we're not at that point yet. We don't have colors randomly like
turning
flipping,
the cows from beef to dairy and back again.
Or maybe we do, and I just haven't come across that particular failure mode yet. But
It's pretty rare.
This used to be a cow. Now it's cheap.
It's pretty rare to have a macro incident where you come along and one of your cows is just floating upside down because the direction bit is flipped on your cow.
Have not seen that yet. Hopefully gravity keeps us in good stead in that particular department. But
Yeah.
What sort of bandwidth do you need per collar, right? Are you dealing with like bytes an hour? Or?
Yeah, an hour, it'd be in the kilobytes realm. So it's not, it's pretty low bandwidth, but we push in the realm of like an IoT device. So if you compare it to like a smart water meter or something like that, those are sending at most once an hour. We're sending on tens of seconds, like there's continuous. So we push the IoT technologies that we use pretty hard from a data transmission perspective. But in the grand scheme, it's like pretty low bandwidth relative to most other things.
So it's low enough bandwidth you could use like low RAW WAN and things if you would.
Yeah, and that's the technology we use for the color. Yeah. Cool. We've modified it a fair bit, but at its core, it's LoRa. Yeah.
Does that end up impacting the number of? Because obviously that's not video bandwidth, right? So even if you could physically put a little webcam in all the collars, you just don't have the bandwidth to support it. Does that impact the features you can deploy?
It can be a consideration. It's a game of constraints and trade-offs. So, but I don't think we've ever been in a situation where like we've had to compromise on product features because we don't have the bandwidth to support it. It's just kind of one of those things where you solve it.
You figure it out.
It may not be as easy as when you're on when you're on a 25 gigabit like network, it's just kind of like the bandwidth is infinite sometimes, you know, or you can kind of think of it that way. It's like, oh, we do have to be intentional about the trade-offs that we make and how we're solving those problems. But we've always found a way, I guess, to date. So yeah.
Cool.
I have one quick last question to end on. In your particular role, whether in life or professionally, in the next 5 years, maybe 10 even, what technical thing, whether it's a hardware thing or an AI thing or a software thing, are you most excited about seeing to come to life?
Oh, interesting. Loaded question. You know, I feel like there are several things, like autonomous driving being one of them. That's not the thing I'm necessarily most excited for. Not that I'm like a super close follower of it. It does feel like we're getting quite close to fusion. And that would have it for like energy, like food production energy is another one of those just fundamental inputs to mankind. And fusion presents a very, very promising way to do that in a much less harmful way. You know, similar to solar, but just orders of magnitude more power being able to be produced in a smaller space. So I guess that's always been it's 10 to 15 years away. And it feels like, and this could be a pipe dream, but it feels like that might actually be the reality now. Similar to autonomous cars, that probably also is in the same boat. I'm just less excited for that bit, I guess. But I think that like the energy is one of those things where we will always consume as much as we're able to produce. Like there's a continual battle between how much we can make and how much we're using. And so that's not going to stop. And companies and people are like, we have all of these great technologies that we can use to make our lives better and improve the planet. And all of those things run on energy. Right now, a significant portion of that energy is actively like working against us from a climate change perspective. And so the quicker we can find solutions to try to mitigate that, obviously the better off we're going to be. So yeah, I guess that would be it.
Fusion, here we come. So I'm going to say thank you, Brad, for joining us today.
Oh, my pleasure.
And schooling us on everything America's Cup and farms.
Yeah, absolutely. Thanks for having me.